Let's determine how much heat will be released from burning 1 mole of butane, considering the fact that the combustion of 0.367 grams of butane has changed the temperature of calorimeter by 7.73 degrees. And it has actually increased the temperature, and this is very important. This means that this is an exothermic reaction, so the heat is released from the reaction minus Q, and this is equal to the amount of the heat that the calorimeter has absorbed. These are equal. So we're going to first determine the heat of the calorimeter, which is going to be the same as the heat of the reaction. So the heat of the calorimeter is equal to the heat capacity, C, multiplied by the change of the temperature. So let's put these numbers here, 2.36 kilojoules per 1 degree Celsius, that's how much heat is needed, times 7.73 degrees of Celsius, and that's how much has changed. So cancel the Celsius and we have that this is equal to 18.2 kilojoules. So 0.367 grams of butane has released 18.2 kilojoules of energy when it was burned. Now, so what about if we have 1 mole of butane? So how do we compare 1 mole with this number, with the mass? We're going to write down that this number, 0.367 grams of butane, C4H10, is producing 18.2 kilojoules of energy. But what we also write down here is that what about if we have 1 mole of butane? That is the question. If we have 1 mole, then this is X kilojoules. So grams and moles. We cannot compare the grams with the moles. We need to compare the grams to moles. So we have one more step, one intermediate step, going from mass to moles. So here the moles are equal to the mass divided by the molar mass, and we have that 0.367 divided by 58.0 grams per mole. So we have 0.00633 moles. That's how many moles we have. So we're going to get rid of the grams here because we're going to compare the moles. So 0.0633 moles is producing 18.2 kilojoules. Okay, that's the heat here that we determined. Now, so what about if we have 1 mole? Here we solve for the X. We divide these two numbers. We're going to get this big number. So 18.2 divided by 0.0633, we're going to get 2,875.19 kilojoules. Or if we were to put it in a chemical equation, I'm going to put a negative sign here. And because it's an exothermic, so minus. And of course here we have a lot of significant figures, so if we round them off based on our initial numbers, 3 significant figures, we'll have about 2880 kilojoules of energy released from burning 1 mole of butane.